All right, quick reminder. Quadratics. When you hear the word quadratics, what does that mean? Parabola. Parabola. Okay, so quad does mean four, but for a quadratic, it's actually x squared. Okay, so maybe it's like a square has four sides, though. You're right, but so if we look here, this is one of our forms. All right, today we're going to specifically focus on our vertex, okay? And we're going to talk about three different ways we can find our vertex. Okay, so if we look here, this one first, we're going to start off ax squared plus bx plus c. That's kind of our generic form. And if we look at this, this is called our parent function. We dealt with this in August. You dealt with this in Algebra 2. If we look at this, where do we know our parent function will start? Zero. Zero. Yep. So also known as the origin. So right here, the origin. And we know the shape is going to be a parabola. Now, to find our parabola, we can use a memory trick. Who remembers what the...
3, 5.
Yes, 1, 3, 5. Yep. So over 1, up 1, over 1, up 3, over 1, up 5. You'll do it both ways. Now, that only works if A is 1. If A is not 1, you multiply 1, 3, 5 by whatever it is. And we'll talk more about that in a minute. Now, I really want to stress this because we have been in the habit of always going from the asymptote. Here's the deal. I know that it looks very similar in that there's nothing down low, but that doesn't mean there's an asymptote on a parabola. Because an asymptote is a line which it approaches without touching. So here is our vertex. There's nothing that it approaches without touching. Okay. So we don't have an asymptote. With that being said, it's up 1 over 1, up 3 from that point over 1, up 5 from that point over 1. We don't always reset to this line like we've been doing on the past test. Okay. Now, we talked about this briefly yesterday. Someone tell me, what would my axis of symmetry be for this particular parabola?
0.
Okay, and what letter?
X.
X equals 0, or there's another name for it. I agree, x equals 0. What is x equals 0 the same as? Well, it is the axis of symmetry, but what is that?
The y coordinate.
The y-axis. That's what I'm looking for. Thank you. So it's x equals 0, or in this case, you could say the y-axis. Now remember, the axis of symmetry is what we can fold it on and it will match up. All right. Now, for the front side here, we'll talk about... Oh, actually, one other thing I want to mention. Okay, so we said that this point at 0, 0, that is known as our vertex. Now, there's one other name I could call that. What do we call something if it's at the very bottom? Minimum. Okay, so that is a minimum. Now, sometimes the vertex won't be a minimum. What else could it be?
Maximum.
A maximum or a max. That is if it opens down. So today we are going to focus on that. How are there different ways to find that vertex? The reason being, if we get into some application problems next week on Monday and Tuesday, in the physical world, parabolas are a very common shape. Has anyone in here taken physics yet or is in it? So you probably did some things where you like throw a ball and it follows the parabolic shape because gravity pulls down constantly. I don't know if you were in that negative 9.8 meters per second squared. Might ring a bell. That is acceleration of gravity down. So it follows this parabola. And the reason we care about that vertex so much is that vertex would be like the highest point your ball got to, okay? Obviously, there's other examples. It deals with this in economics sometimes. Parabolas are all over, so we want to know how to analyze them. So the vertex is what we'll focus on today. Remember, we said this was a minimum. You might want to do a little sketch here. If it was like that, it would be a maximum, okay? And one other thing you might want to make a note of, just so we don't have to struggle with it next time, 1, 3, 5. Okay. Now, we're going to start. These bottom two are like what we did yesterday. This is called our vertex form. And the reason it's called a vertex form is because it's so easy to find the vertex. It's based on the shift that occurs. So if we look at example A, what does this shift mean? Okay, up 1. And what does this shift mean? Right 2. So if the whole thing is shifted right 2, up 1, normally it starts at 0, 0. Where will the vertex be? Double check. 2, 1. Yes. It's okay. 2, 1. That is our vertex. Now, next, we need to care about one more part of this. At the front here, what is our A term? 1/2. Now, first question to ask yourself, is that positive or negative? So we know it will open up, and that means that vertex is a minimum. It's a minimum. It's positive, so it opens up, so that's a minimum. Okay. Now, the fact that it is 1/2, instead of using 1, 3, 5, what do I do? Yeah, divide each one by 2 or times by 1/2, which you said 0.5 or 1/2. What's next? 1.5 or 3/2, and then finally, bless you, 2.5 or 5/2. Good. Okay, now you might be saying, why is that? It is going to be half as tall. It gets squished, right? Another name for that squish starts with a C. We call it a compression usually, but condense, I understand what you mean, so good. All right, so 1/2, 3/2, 5/2. Now, remember, when we graph this, that means some of your dots won't be right on a point. That's okay. You guys are capable. Okay, up 1/2, up 3/2, and then up 5/2. And if we look up at the one above, you can see this got kind of squished down. It gets wider quicker. All right. That point, 2, 1, that's our vertex, also known as our minimum in this case. All right. I would like you guys to try number B for me. While you do B, pay attention. There's one thing that's a little different at the very front. You guys will know what to do, though. So give letter B a try, please. All right, so let's talk about the second one here. So what shifts occur?
Down 1, left 1.
All right, down 2 and left 1. And then what does this mean? Flip over X, or if you prefer, you can just think of it as down, but that's the same thing. So it's up to you how you think about this with 1, 3, 5. What will 1, 3, 5 become?
-2, -6, -10.
Okay, so either you can think of it as negative, or you can say 2, 6, 10, but then no, it flips. Either way, it's going down at that rate. Okay, so where is my vertex at?
-1, -2.
Okay, good. And what will it be, a min or a max? Max. Oh yeah, it's crazy. So, ski, right? All right. That's what Aiden said. And he didn't even give me anything. All right, I was trying to tie it all back to, when was that? 2 weeks ago. Man. All right, I probably used it wrong. But what do we do now?
1 over, down, -2.
Okay, over 1, down 2 on both sides. Then over 1, down 6.
And that's going to get you to the bottom.
Right, and technically it keeps going. You can keep going, but we don't need to. I hope we understand the 1, 3, 5 rule. It's not like it stops at. It's not like that's where it ends, right? This keeps going. That's just it. Technically, is a 1, 3, 5, 7, 9, 11, 13. Right? We could keep doing that, but we don't need to. Okay.
You know what makes sense to me? I used to not get it. Now I get it. I wish I didn't get it.
That would have been nice. All right, that's the first way. We'll call that the transformation kind of method because we go based on a shift around. Now, the reason I don't call it a translation, does anyone remember in geometry, what was a translation? When it slides, yeah. And that's what we do for most of it, but why do I want to call it transformation instead?
Because when I move it, it's not a shape.
Well, I agree, but it still moves. It does a transformation, but what else do we do? Or a translation, but what else do we do?
Go down.
Oh, yeah. And go down, which is called
Flip.
a flip or a...
Shift.
No, what's a flip?
A flip.
A flip is... What's the math word for that? You already said it.
What?
I don't know why we're struggling with this. What happened to this? It's not facing up.
Down.
Yeah, so a flip, which is a... We can't come up with this math word?
Maximum. Translation. Transduction. Translution.
What is the math word for flip?
Flip. It's flip.
No clue.
You guys all passed geometry?
Reverse.
Inverse.
Inverse. Inverse.
No. A reflection.
Oh. I was also thinking of my.
Yeah, like, come on, you guys know that word. I agree, it's a flip, but it's a reflection. Okay. Yikes, that's on our video. Okay, so. All right, I promise if you're watching this, they know more than it seems. Okay? All right. Flip to the back or reflect. No, flip your paper over. Okay, so at this point, let's talk about what to do with our calculator. You need a calculator to do this. Here's the deal. If we were solving these two, you probably actually wouldn't use this method, but we're going to teach you how to on a simple one, so that way you can use it on the more advanced ones next week. Okay, so using your graphic calculator to find the max or the min. This can save you a lot of time if it is not written in the form we just had. You see how this is not vertex form. So I don't want you to look at this and say, oh, it's up 7, it's left 4, and tell me the vertex is at -4, 7. No, that's not how we do it, okay? So everyone take your calculator, and let's start. Go to y equals, and let's graph that first one. So what is it, x squared? So everyone grab a calculator, do x squared. Oops, I double squared. So x squared, what is it, plus 4x. So x is right beside the green button, beside the alphabet. Plus 7. Okay, we go and we graph it. And here's the deal. On this one, probably most of you could figure out what the vertex is just by looking at it. And that's our end goal, but I'm going to show you a different way to do it because sometimes we'll need this other method. So to find that, has everyone got it graphed?
Yes.
No. Come on. Some of us haven't even picked up a calculator. All right, so now, second trace, or that gets us that calc, C-A-L-C. Now, we are going to hit second trace. We want to calculate, if we're trying to find the vertex, which of these words would match what the vertex is in this particular problem? Minimum. It opened up, so it's a minimum. Obviously, if it opened down, you're going to choose maximum. But those are our two choices. Okay, so I go to minimum. I hit it. And it pops up like this. And it says the words here, left bound. Now, bound is short for boundary, so the edge. So when I say left bound, I need to choose a point that is on the left side of the vertex. Right now, mine is clearly not on the left side. So I move it over, just hit the arrow key, over to the left. It can be anywhere on the left side of the vertex. You guys will not all choose the same spot, okay? I hit enter. Now it says right bound. So arrow it back over, choose something on the right side.
Where's enter? Oh, never mind.
Okay. We hit enter. Okay, now it says guess. Now, what does guess mean? Guess wants you just to put something in between. Go get one. All right, we want something in between there, okay? So, guess somewhere by the vertex. You might not be exactly right. That's okay. It doesn't really matter as long as you are between. Now, your guess cannot be like, if I go over here and guess, that's unrealistic, right? Have it between your left and right bound. I hit enter. Now, here's the thing. It takes those things and it calculates. It does some rounding and at times is off a little. Is mine really at -2.000001? We are going to say it's at -2, right? But that's just because of the rounding that occurs, okay? So, what is my vertex?
-2.
And what's the y value?
0.
No,
Or
3. And what did we say that was? A min or a max?
minimum.
Minimum.
Next one.
All right, give letter B a try. Do the same approach and try letter B. So at times you might do negative b over 2a instead to find the vertex. So this is for the x value. Now, to do this, so hang with me, guys. We're almost done. Let's start by labeling. Which of these 2, 8, or 5? Which one is my a?
The 2.
2. 8 is my b, and 5 is my c. Okay, so negative b over 2a. This tells us h, which is the x value of our vertex. So, yep, opposite of whatever b is. So that'll be negative 8 in this case. Over 2 times, what is a?
2.
2. And at this point, we get negative 8 over 4, which gives us negative 2. That's my x value. Okay, now, what will my y value be? To find a y value, once we know an x value, what can we do? Plug it in. So we'll take negative 2, and I'll plug it in right here and right here. So 2 times negative 2 squared plus 8 times negative 2 plus 5. Okay, this is all stuff you've done before. Now, follow PEMDAS. So parentheses, there's nothing to do in there. Exponents. What does negative 2 squared become? 4. We multiply. We get 8 minus 16 plus 5. What does all of that combine to? Negative 3. So, where is my vertex at? Negative 2. As my vertex, it is also known in this case as a minimum. Yes. Way to persevere. Well, if this parabola opens up, the vertex will be the lowest point. If it opens down, the vertex will be the highest point. It'll be a maximum.
Because there's no negative in front.
There's no negatives, so we know it opens up. What? All right, give the second one a try. Then we're going to graph it. So find the vertex and then graph it using the 1, 3, 5 idea. All right, go for it. All right, so first thing, well, it's up to you. You don't have to do this, but A, B, C. So to find our x value, negative b, what do I put? Negative 6 over 2a, which 2 times 1/2 is 1. So negative 6 over 1 or negative 6. That's my x value of my vertex. Now to find my y value, plug it in. So 1/2 times that negative 6 squared plus 6 times negative 6 plus 12. Whoops, plus 12. All right. Most of us, I think, did the first part correct. We said negative 6 squared is 36. Half of that is 18. Then I saw a couple of us make a mistake here. 6 times negative 6? Negative 36. Bloody plus 12. All right. So now we add them all up, and what'd you get? Negative 6. So my vertex is negative 6, negative 6. Will that be a min or a max? Min, because A is positive. A is also 1/2, which means it's not the 1, 3, 5 rule. What will it?
It's the 0.4, so 1/2.
Yeah.
Over 2.
So if you went up 1, over up 3, up 5, yours is too steep. We got to do 1/2, 3 halves, 5 halves, just like we did on the front. Now, of these three rules, these three ways, I think you guys, well, yesterday we worked on the one on the front page, and this last one you have done before, even if you don't remember it. We're going to focus on the calculator one. You've got 15 minutes left. That should be more than enough time. Get it done. If for some reason you don't finish, there's a few practice ones on Delta. It's all just using the calculator. So do that. You really don't even have to think. I'm just making you do this because I want you to be good at using this calculator. Okay, it's a tool. We need to know how to use it. So get it done. It's pretty mindless, but get it done just so you can practice. Here's the deal. Listen carefully because I know someone's going to still mess it up. On the delta, it asks you for what you get. It does not want the ordered pair. It just wants the y value. So just give the y value. That's like your output it's asking for. Okay, so when it asks you what you get, give the y value only. And make sure you round to the nearest hundredth. I believe that's what it asked for.